There, this video is on AP Calculus BC 2024 Solutions FRQ5. A couple of Euler's thing here, FTC, let's find that out. The first one says that a function is twice differentiable for all x, and it's already given that f of 0 is equal to 0. The values of the derivative of the function, all the values are given in this table. So for positive x, the value of another function h is defined by this integral. So we have to find the value of h prime pi and show the work that leads to our answer. So this is a clear case of FTC1. So I'm going to find the derivative of h, which is h prime, by doing just inside the integral. I'm just going to replace x with, t with x, and everything else just remains as it is. We need the value h at pi, so replacing x with pi, we have square root of 1 plus f prime pi whole square. And what is f prime pi, guys? The value of f prime at x equal to pi is 6, right? So I'm just going to replace this with 6. 6 square is 36. 36 plus 1 is 37. So the answer is the square root of 37. I hope this one makes sense. The next question talks about what information does this provide about the graph f. What information does this provide about the graph of f? Don't you think this kind of matches the formula for the length of the curve? Because what is the length of the curve of any function? The length of the curve from a to b is given by the integral from a to b of square root of 1 plus f prime x whole square dx. And that's the exact thing which is written over here. If you realize the value of a is 0, the value of b is pi, and f prime is just f prime. So can we agree that this expression denotes the length of the curve fx from 0 to pi, So that is what this expression represents. Next one, they are talking about Euler's method. So we need to use a Euler's method to approximate f of 2 pi and show the computation. I think we're going to make a table here starting from x. In fact, let me make xy. Then I need the derivative at that particular, x comma y at that particular point. I need the value of delta x. I need the value of delta y, which is nothing but the derivative of the function times delta x. And then I have the new point, and the new point is nothing but x plus delta x and y plus delta y over here. So this is what we have here. All right. Oops. Okay. Starting from the first point, what is the first point? Okay, so I need to go back and pull this information as well because I would be needing this. So let me quickly copy and paste it over here. Let me paste it here. I think we don't need that much of space. Okay. The starting point is 0, 0. How do I know that? Because that's given in the question. So that's 0, 0. That's what we have. What is the derivative of the function at 0, 0, guys? I know that the derivative of the function when x is 0 is 5. So I'm going to write 5 here. What is delta x, guys? Remember that they need 2 equal steps to reach from 0 to 2 pi. So the delta is going to be the final value minus initial value over 2. Final value is clearly 2 pi. Initial value is clearly 0. 2 step size means divide by 2. So this comes out as pi. So this over here I have pi. So the value of delta y will be dy over dx, which is 5, multiplied with delta x, which is pi. And so new value will just be x plus delta x. And what is x and y? They are just 0, 0, right? So that's going to be 5 pi. And do I really interested in the y value at this point? Well, I have to eventually write. So let's do that. This is going to be, what is delta y, by the way? X plus delta x is going to be 0 plus pi, which is just pi, and this will be 5 pi because y is 0 and delta y is 5 pi. I hope this makes sense. The next iteration which we have is starting from pi comma 5 pi. What is the derivative at pi, guys? The derivative at pi is 6. So what is the delta x? That's still pi. So what is the delta y? That's going to be the derivative, which is 6 multiplied with the delta x, which is pi. So that's 6 pi. So the new value comes out as the value of x will be the initial value, which is pi, plus the delta x, which is pi. So pi plus pi is 2 pi. And y plus delta y will be the initial y is 5 pi. The delta y is 6 pi. So 6 pi plus 5 pi is 11 pi. And I think that's what we needed, right? They needed the approximate value of f of 2 pi. So at 2 pi, the approximate value is 11 pi. So that's how I'm going to say that f of 2 pi as per Euler's method is approximated as 11 pi. I hope this makes sense. And the next one is, I think this is the last part. We need to find this. So I think this is a clear case of integration by parts because there are two parts which are multiplied. So let's do that. What is going to be the u? U is going to be the t plus 5 expression, and dv is going to be the other thing, which is cosine of t over 4 dt. I'm going to need the value of du and v anyway, so I'm going to find that right away. So du will be just dt. Why dt? Because the derivative of t is just dt and the derivative of 5 is 0. And integration of cos of t over 4 is going to be sine of t over 4 with a 4 outside, or if you want to understand it, 1 over 4 in the denominator. That's how we do it. And this is what we have. So v is going to be 4 sine t over 4. So what will be the integration of u v? Integration is, not uv, u dv. Integration is uv minus v du. What is u? It's t plus 5. What is v? 4 sine t over 4 minus integration of v du. What is v? 4 sine t over 4. And what is du? Du is just dt from here. All right, I'm going to continue over on this side. So I think I almost have my answer. So if we simplify this a little bit, the first term will just be 4 times t plus 5 sine of t over 4 minus 4 comes out. And what is the integration of sine? Sine is minus cos, and remember that this is 4 is going to contribute as well. So minus 4 cos t over 4, and obviously plus c. So finally, what is our final answer? Is 4 times t plus 5 times sine of t over 4. Double negatives will become positive. 4 times 4 is 16. So 16 cos t over 4 plus c. Just going to box it up. And I think this is our final answer. I hope this one makes sense. Any questions, please post it on the comment section. I'll see you in the next video. Bye-bye.